What's up, everybody? This is Danny Mathematics here with another example to explore. And today, guys, I want to go over example 2 and example 3 of finding the volume of a 3D shape, right? Finding the volume of 3D shapes. I want to go over example 2 and example 3. And in both of these examples, the 3D shapes fall in the category of prisms, right? And remember, guys, in the last video, I explained it. A prism is a 3D shape that has two bases, right? A top base and a bottom base, right? The other category is pyramids. If you know how a pyramid looks, it only has one base, but a 3D prism has two bases. Like this cylinder right here, it has a circular base, right? This triangular prism has a triangular base, rectangular prism, rectangular base, and so forth and so on, right? So let me just get my calculator real quick. All right, real quick. So we understand, guys, that finding the volume of a 3D shape is finding how much capacity can I fill it up inside, right? So for example, my best example that I always come up with, imagine you draw your bath water, right, in the tub, but you forgot that you had the bath water running. So when you go upstairs or you go to your restroom, the water is all the way up to the top. It's about to overflow. That's volume because we filled up the tub all the way within, all right? That is volume. So it's how much mass or how much of whatever you're filling it in with, how much you can put inside of that 3D shape, okay? How much you can put inside, all right? So for example, even another example, if I have a cup is shaped like a cylinder. If I was to fill up my cup with water, right? Fill it all the way up to the top, I'm getting the volume of the cup, all right? So just wanted to explain that, guys. So we understand, guys, that finding the volume of a prism, we follow this formula. So we're gonna do example 2 first, and this is an example of a cylinder. A cylinder is a prism with circular bases, all right? So our volume formula, guys, to find the volume, we do V, which is volume, equals base, the big B, right, which is the area of the base, not the base, but the area of the base. That's why it's a big B, times the height of the whole 3D prism, okay? So that is our formula, all right? And this formula only works for prisms, okay? When it comes to pyramids, which I would do in later examples, you will see that the formula will just be a little bit different. It will be mostly the same, but just a little bit different, all right? So this is the formula. Now, big B, guys, remember, big B represents the area of the base, So depending on the shape of the base would tell us the area formula we're going to use to find the area of that base, all right? So in this particular example, guys, the base is, because it has two bases, all right? It's a base down here, and there's a base up here, all right? This cylinder has circular bases. So to find the area, big B is going to turn into the area formula of a circle, all right? So I'm going to write this over here, guys, big B. And underneath, guys, I'm going to put area, okay? Area of the base, right? Of base. I'm just writing this so y'all know what big B represents. It represents the area of the base. And in this particular situation, guys, the base is a circle. So it's going to turn into the area formula of a circle, all right? Which is pi times the radius to the second power, all right? Which is radius times radius, okay? Now, here's what I tell all my students, right? If you're doing a volume problem and they're asking for the approximate, they just want an estimation. They just want you to get close to the exact volume, okay? So if they're asking for the approximate, guys, right? The value of pi that we're going to use, right? The real value of pi, guys, is 3.14. So if you wanted to know the actual volume, like the actual volume, right? Down to the decimal, then you're going to use pi, which is 3.14. But if the problem is asking for the approximate, meaning that we just want to just get the estimation, approximate, then all you have to use is just 3. So here are the two values that you can use for pi. For you to get the exact, and let me put the word exact. For you to get the exact volume, you have to use 3.14. But if the problem is asking for the approximate, which on the middle school level, most of the time this is going to ask for the approximate, you can just use 3 as pi. All right. Now the radius, guys, is half of the diameter. All right, of the diameter. So in this particular case, guys, the diameter, which is the distance across the circular base, is 18 feet. Right? But we know that the radius is halfway across the circular base, right? Which is half of the diameter. So the radius is 9, because if you divide 18 by 2, you will get 9. So the radius is 9. So we're not going to use 18. That's the diameter. The radius is 9. It's half of 18. All right. So now, guys, all we're going to do is, and in this particular case, guys, I want to know the approximate, right? The approximate volume, right? Or the approximate area when it comes to the base. All right. I just want to know the approximate, and we're going to get the approximate volume. So once again, we know that pi is 3.14. But instead, guys, we're just going to use 3 because we're just going to get the approximate amount, all right? Times r to the second power, right, is 9, right? So I can write to the power 2, or I can put 9 times 9, because 9 to the second power is just like saying 9 times 9, right? So you can just put 9 times 9. Now, what we're going to do is we're going to solve. I know that 9 times 9 is 81. So I'm going to do 81 times 3. Which is 243. So the area of the base, of the circular base, is 243 square feet. All right, that is big B. But once again, guys, that is not our final answer. That is just the area, right? It's just the area. All right, now we got to find the volume. So in order for us to find the volume, we're going to have to multiply the area by the height of the whole cylinder, which is the volume formula. So once again, we know that big B, which is the area of the circular base, is 243 square feet. And then we're going to multiply by the height of the whole cylinder. The height of the whole cylinder, or from base to base, is 25 feet. So I'm going to times that by 25. I'm going to multiply that by 25. So let me go ahead and do that. Let me actually get another red marker, because that one is kind of going out. All right, so we're going to times that by 25. So now we're going to do 243 times 25, which is 6,075. All right, so the approximate volume, right? The actual amount is actually a little bit more than this, right? But we just wanted the approximate. So the approximate volume is around 6,075 cubic, right? Which is to the third power, cubic feet. All right, so that is the volume. So if we was to fill up this cylinder with water, right? We can fill it. We can fill up 6,075 cubic feet of water. If we wanted to fill this up with water, or fill this up with Skittles, or whatever you wanted to do, guys, you have a space of 6,075 cubic feet of space within. All right. So that is how we find the volume to that. Let's go ahead and do the last one, guys. Once again, it's the same thing. We're going to start off with the volume formula, which is V equals the area of the base, which is big B, times the height of the whole triangular prism. All right? Times the height of the whole triangular prism. Now, in this particular example, guys, if you notice, our bases are not circles. They're actually triangles. So the area of the base, I'm going to have to use the area formula of a triangle, okay? So let's go ahead and do that, guys. So big B, and let me put a triangle underneath so you know what I'm talking about. And even up here, let me put a circle on top so you know what I'm talking about, right? Because that's the shape of the bases. So the base is shaped like a triangle, right? So I'm going to use the triangle area formula, which is base times height divided by 2. The base, which is the horizontal side of the triangle, times the height of the triangle divided by 2. So let's go ahead and do that. So base times the height divided by 2. Okay? So what I'm gonna do is, guys, I'm just gonna just draw the triangle right here, which is this. That's the base, right? As you can see, guys, the base or the horizontal side of the triangle is 12 inches. All right? And as we can see, and that's small b, as you can see, the height of the triangular basis. And once again, the basis is going to be the same dimensions. It's 18 inches. It's 18 inches. That is the height. So all I have to do, guys, is I have to do 12, which is the small b, the horizontal side, times the height of the triangular base, which is 18, and then divide that by 2. Okay, so let's go ahead and do that, guys. 12 times 18 is 216 divided by 2. I believe it's 108. Yes, it's 108. So the area of the triangular base is 108 square inches. Okay, that is big B. Okay, but once again, guys, this is not the final answer. We just need this value. We need to plug this value back inside of the volume formula to find out the volume. So once again, guys, we found out the area of the triangular base, which is 108 square inches. And then we need to multiply that by the height of the whole prism. The height is from base to base. So there's a base in the front and there's a base in the back, and the distance is 15 inches. So I have to multiply that by 15 inches, all right? And then I'm gonna have the volume, which is the capacity that this triangular prism can be filled up within, right? The capacity within, okay? So let's do 108 times 15, which is 1,620 cubic inches. So that's how much space that is inside of this triangular prism, all right? That can be filled, which is 1,620 cubic inches, which is inches to the third power, because we're dealing with 3D, right? So once again, guys, that is how we find the area to each particular prism, okay? So once again, guys, this is example 2 and example 3. I will come out with 2 more examples of prisms, and then I'm gonna move on to pyramids. Pyramids is gonna be a little bit different, but it's essentially gonna be the same process. Thank y'all so much, guys, for tuning in. Talk to you next time.